Welcome back to another video. Today is a beautiful day. I hope you're having a great day. You're blessed to be alive and to be able to watch this video. So be thankful for your blessings. In this video, I am going to be talking about annuities. Alrighty, and so just starting off, we're going to talk about what is an annuity. Okay, so if you've been keeping up with the videos, the previous video we talked about compound interest, and in the video before that we talked about simple interest. Simple interest is when you make one lump sum or you deposit one lump sum into an account and you only draw interest on the principal. And then compound interest was when you deposit one lump sum into an account and then you gain interest on that principal amount, plus you gain interest on any interest that has been added to the account. Okay, so interest could be added like every month or every day or every week or quarterly or semi-annually. So we looked at all those options. Well, today we're going to talk about annuities. So now with annuities, you don't just deposit one lump sum of money. You actually make regular deposits into an account. So one prime example of an annuity would be like a retirement account. If you work for a company that has a retirement plan, then they take out like a certain amount of money every month, and that money goes into your account. And so your money is building what you're putting in, plus the interest is being calculated on that money. And so that is an annuity. And so we're going to look at how to calculate annuities. So the formal definition for an annuity is a sequence of equal payments made at equal time periods. Alrighty. And so we're going to look at how to calculate the value of an annuity. So there is a formula on how to calculate the value of an annuity, and it looks like this. A is equal to P times 1 plus R over N raised to the N times T minus 1 all over R divided by N. Now those R's and N's and P's and A's are the same variables that we looked at previously in a previous video, but just in case you missed the previous videos, P represents the principal amount, or in this case, the payments. So how much are you paying each month or however long you're paying, whatever the time period is. R represents the interest rate, and you always convert the interest rate to a decimal. T represents the time in years that you're going to be making these payments. N represents the number of compounding periods per year for the interest. So if your financial institution calculates interest monthly, then N would be 12. If it calculates interest annually, N would be 1. If it calculates interest quarterly, N would be 4, and so forth. Okay, and so that's your N. And so A represents that future value, the value of the annuity after that certain time period. Okay, so let's look at an example, and we'll use this formula for that example. So for example 1, suppose that at age 25, you decide to save for retirement by depositing $50 into an IRA at the end of each month that pays 5.5% compounded monthly. So you want to figure out how much will you have from the IRA when you retire at the age of 65, and then you want to find the interest. So how much of that is interest, all right? So going back through the problem, we want to identify all of the variables. So P, which is the payment amount, and it says you're going to deposit $50 monthly. So P will be 50. You also want to identify R, which is the interest rate, which is 5.5%. But remember to convert that to a decimal, you move it to the left 2 times. So this is left for me, that would be left for you. So that would be 0.055. So that will be your R. Now it says that the interest is compounded monthly, so that means your N is 12. And then it doesn't tell you the exact time, but it does say you want to retire when you're 65. So it says you start this when you're 25, and if you want to retire when you're 65, that means you're going to do this for 40 years. So your T would be 40. All right. So now you have all of your variables, your P, your R, your N, and your T. And so now you want to figure out what is that future value of that annuity. So you want to plug all these into your formula. So 50 times 1 plus 0.055 over N, which is 12. All of that raised to the 12 times 40 minus 1, all of that over the 0.055 over 12. All right, and then the rest of that is just plugging it in the calculator already. So I'm gonna grab my calculator here and we're gonna plug away. So now with these, the most errors that I commonly see is people entering it in the calculator wrong. Again, I would start with the parentheses and just kind of work your way out. So I would start with the 0.055 divided by 12 and then add 1 to that. And once you add 1, you want to raise that to the power of 12 times 40, which is 480. Then you want to subtract 1 from that. Okay, so when I get to this part, I'm actually at, I'll write it out for you. I'm actually at 50 times 7.979764757. Now you don't want to round any of these numbers because you end up with a rounding error as soon as you round. So you do want to write out every digit. So I'll multiply that by 50 and then I will divide that by 0.055 over 12. And I get, so 0.055 over 12. So you can actually divide out 0.055 over 12 if you want to. But you get long digits also, 0.00458, and then 3s repeating. It just depends on how many digits your calculator will take it out. But when you calculate all of that, you end up getting that A is equal to 87,051 and 98 cents. And on some of these problems, it may ask you to round to the nearest dollar. But usually when it's money, you round to the nearest cent. But on some of these, you have to round to the nearest dollar. So if you round that to the nearest dollar, this squiggly line means approximately. It means this is approximately $87,052. So that's how much you will have in that account after making those $50 deposits for 40 years, all right? So now the second part of this is we want to figure out how much of this is from interest and how much of that is money that you actually put in, okay? So I'm going to have to erase this to write that out. But just know that it was $87,052. $87,052 if we round it to the nearest dollar. So that's how much you'll have. Now let's calculate the interest. So now in order to figure out how much of that $87,052 came from interest, we need to figure out how much did we actually deposit. So the total deposits will be found by taking how much you deposited, which was $50. We did it every month, so there's 12 months in a year, and we did it for 40 years. So this will actually give you your actual deposit. So 50 times 12 times 40, and you get $24,000. So we only actually deposited $24,000, alrighty? So now if we want to figure out how much of the money came from interest, so to find the interest, we'll take the total amount we have in the account, which is the $87,052, and we'll subtract how much we actually deposited. So if you take the $87,052 and subtract the $24,000 from it, the interest ends up coming out to be $63,052. So that means if you make $50 payments monthly in that account that pays 5.5% interest, and you do that for 40 years, you'll end up with $87,052, and $24,000 of that came from money that you actually put in, and $63,000 of that actually came from interest. So that's really a good return on your investment. Even though $87,000 is not a lot to retire on, realistically speaking, but that is a start. So the more you want to have, the more you will want to put in each month, okay? All right, sometimes with an annuity, you will want to calculate how much you want to pay in order to have a certain amount after a certain length of time. So you might say, I want to retire with $1 million. So then you can work backwards and actually figure out how much do you need to put in each month in order to have that $1 million after a certain length of time. So the formula you will use for that is that same formula, but solve for P. And I'm not going to actually go through and show you how to solve for P. I'm just going to give you the formula. So it's P is equal to A times R over N. All of that over 1 plus R over N raised to the NT minus 1. All right, and so I'm going to put this in brackets because all of this is divided by all of that, okay? And so this is the formula that you will use whenever you want to figure out what you need to pay each month or each quarter, however long whatever your increments are. This will tell you what your payments need to be in order to reach that end goal. So let's look at an example. So for example 2, suppose that once you complete your college education and begin working, you would like to save $20,000 over 5 years to use as a down payment for a house, which is a reasonable amount. You anticipate making regular end-of-month deposits in an annuity that pays 6% compounded monthly. And so what you want to do is you want to figure out how much should you deposit each month, and then you want to figure out how much of that will come from deposits, and how much of the $20,000 will come from deposits, and how much will come from interest. Okay, so how much of that will be actually money that you put in, and how much of that will be money that you got from investing. Okay, so let's identify our variables. So we're solving for P this time, so that means we should be able to figure out what is A, what is R, what is N, and what is T. Okay, so A is the future amount of the annuity, which we want it to be $20,000 because that's what we want to use for the down payment. We're going to be making these payments monthly. It said that, 6% compounded monthly. So your interest is compounded monthly. So N would be 12. And then it's 6% interest. So your R would be, convert that to a decimal, 0.06. And we're going to do this for 5 years. So after we graduate from college and we start working, we're going to want to save for 5. We're going to give ourselves 5 years to have a down payment for a new home. Okay. So these are the variables. And now we want to just plug them in the formula to figure out what the payment is. So P would be equal to A, which is 20,000, times R, which is 0.06 over N, which is 12, all over 1 plus 0.06 over 12, so that's R over N, raised to the N times T, so 12 times 5, all of that minus 1, all right? So this is the formula, and now you just want to plug it in your calculator and calculate it, all right? So again, I would start with the bottom parentheses and work that out. So 0.06 divided by 12 is 0.005. If you add 1 to that, you get 1.005. Raise that to the 12 times 5. 12 times 5 is 60. So raise that to the 60th power and then subtract 1 from it. Now, if you do that, you get a long number. Again, you do not want to round. So I'm going to write all this out just so you can know what I got when I did the bottom part. 0.3488501.525. And then for the top part, you would do the 0.06 divided by 12, which is the 0.005 times 20,000, and you get 100 in the top. So if you do 100 divided by that number, you actually get 200. You get P to equal $286.66. All right. And so if it tells you, most of these, it will tell you to round to the nearest dollar. So that'll be approximately $287. So your monthly payment would be $287 in order to have that $20,000 in 5 years. All right. So you'll put $287 in this account. And so now we want to do the second part, which is calculate in the end when we get our $20,000, how much of it will be from the money that we put in the account and how much of it will be from interest. So we need to first calculate the total deposits. So our total deposits will come from the money that we paid. So if we're paying $287 a month, So it'll be 287 times 12 because there's 12 months in a year and we're doing this for 5 years. So it'll be times 5. So 287 times 12 times 5 is 17,220. So that means 17,220 comes from deposits, money that we made or money that we put in. And then the interest would be the 20,000, and that's supposed to be equal. Will be the 20,000 minus that 17,220. So if you subtract 20,000 minus 17,220, you get 2,780. All right, so that lets you know that of the $20,000 that you'll have at the end of the 5 years, 17,220 of it came from money that you actually put in, and 2,780 of it came from interest from sitting in the account. Okay, so that's how you would calculate your interest from your annuities, and that's how you would calculate the total value of the annuities, and also how you would calculate the payments that you would need to make on a regular to reach that certain goal. All right. Hopefully this makes sense to you. Again, this is very applicable to daily life, especially as you become grown and start doing grown folks things like buying cars and buying houses and investing, things like that. So, yeah, hopefully this is helpful. If you found it helpful, please hit the like button. And if you have any questions, don't hesitate to ask them. And I will see you all in the next video. Thanks for watching.